Welcome to the Robot Podcast. I'm Fran Scott, maker, demonstration developer, and massive engineering fan. Every week, my guests and I will be exploring the exciting stories of how robots can, will, and are impacting our everyday life. From sorting food to cleaning our hospitals, from manufacturing cars to creating sustainable buildings. Robots are pushing the boundaries to meet the demands and challenges of a changing world. And as technology improves, it is becoming easier for robots to adapt and perform multiple tasks that, behind the scenes, offer huge societal benefits. It's all about flexibility and simplicity. This time, let's talk about how robots are driving change by helping with EVs. EVs are, if you don't know, electric vehicles, and they have the potential to dramatically reduce our reliance on fossil fuels, while still enabling us to get from A to B. And robots are a critical part of their story. To help us discover that story, I am, of course, joined by our specialist panel, which today is made up of Patrick Matthews, Director of Global Assembly for Robotics Auto OEM.
Good afternoon. Hello. Glad to be with you.
Good to have you. And Ade Thomas, founder of Green TV, who also heads up the EV Summit and World EV Day.
Hi there. Great to join you both. Thanks very much indeed.
Brilliant. And later on, we'll also be hearing from Isobel Sheldon, who, with Britishvolt, are aiming to build enough batteries to keep Britain driving and hoping robots will lend a hand. Patrick, can you explain to us a little bit about what's going on inside an EV and how they actually work?
Sure. When you first see an EV on the road, you may not see that there's so much different looking at the outside in. You know, the wheels, the doors, the hoods, they all look the same. But when you take a look inside or you pop the hood open, you're going to start to see some differences inside there. When we look in there, there's differences mainly in the powertrain, some other areas, but mainly in the powertrain. We see that in a traditional internal combustion engine, we see that they have a fuel tank. That's in an EV kind of replaced by, in the simplest terms, a battery. We then have the engine. The petrol engine is replaced by an electric motor and a drive controller, and they're radically different pieces of equipment. Then we look at the transmission. A big change in EVs is the electric motor can spin both directions. So no longer do we need a transmission that has to do the reversing. The electric motor can do that reversing. So we see it's really replaced by a simpler gearbox. And then we see that the exhaust system is gone. Not there, don't need it. We also see that oil in the engine's gone, don't need it. So it's just a lot of different pieces that are really much simpler to design and build.
So it's quite apparent that EVs and those cars that use combustion engines are very different on the inside, but are they different to drive? What's your opinion on that, Ade?
Yep, the user experience, the driver experience of an electric vehicle is very, very different. So it's quieter, there's no gearbox, but they are also, if you decide to put your foot down, a whole lot more exhilarating because the acceleration is just immediately there, right from 0 miles per hour up to however many miles per hour you wish to go. But as I'm a good father figure with 3 young sons, I drive like a very old person in calm mode most of the time.
And what's the whole car ownership experience like in terms of, because obviously with an internal combustion engine, you've got to fill it with fuel. But obviously with an EV, it's about charging. Is that experience, I can imagine that's quite different as well.
I mean, I think the charging infrastructure side of things does still need looking at. You know, charging infrastructure firms do like to say that it's an issue which is being resolved, but, you know, it still is quite a tricky one for a lot of drivers. But it's not quite there yet. In terms of the mechanics, the process of charging an electric vehicle versus fueling up with petrol, you have to work it into the context of your life. It's a different experience. So, you do things like look to charge your car overnight. You don't obviously go to a forecourt and hang out on a petrol station overnight, but, you charge your car outside your house overnight. And that's just the way you rethink the experience of providing fuel for an electric vehicle in a very different way to providing fuel for a combustion engine vehicle.
Patrick, how common are electric vehicles?
The electric vehicle is starting to really take place in certainly in different regions of the world. In Asia, they're very popular, and you see them all the time. In Europe, with the regulations and stuff, they're coming very fast. In the U.S., we see them, but they're not. We're lagging behind, but they are becoming very much more popular than they have been. You know, there's a big push to the environment, and there's a big cost benefit that we're starting to see with them as well. So I think you're going to see them in ever-increasing numbers in the field.
Do you think there'll come a tipping point? Because obviously there are reasons why people are holding back from buying them. And obviously the more people that buy them, the more infrastructure follows. Do you think we'll see a tipping point where enough people are buying them so the infrastructure accelerates, so actually then more and more people buy them, and then that just keeps on going up?
Absolutely. I think that, electric vehicles really around the turn of the century, the 1800s to the 1900s, were here. In fact, we used to have them, and then they kind of lost out. And they lost out because their cost wasn't there. They had many of the same benefits that we're looking at today, but their cost just wasn't there. And the petrol engines and stuff, technology grew fast enough that the prices come down. And we're seeing that same phenomenon now happening now with the EV. Okay, as the regulations and the CO2 emissions and as pointed out, we're concerned about the environment, and we want to turn to EVs. And as their prices come down, I really think that in the long term, you're going to see the EV replace the ICE as soon as those prices come down to a place where us, the consumers, will accept them fully.
The ICE being the internal combustion engine, yeah?
Internal combustion, yep.
And what are the potential energy savings of switching to electric vehicles?
There's a huge opportunity here with the shift to electric vehicles to totally decarbonize the transport sector. The International Energy Agency says that in 2020, 90% of new electricity generation will be renewable. So that's a really powerful shift to the decarbonization of the energy sector, and therefore, as a result, the battery electric vehicle transport sector.
Talk to me more about that, because there are groups of people who look at EVs and think, well, yes, there's no carbon emissions when you're actually driving, but they feel as if the carbon emissions have just been shifted to another part of their manufacture. Talk to me a bit about that.
Well, it's correct if the energy is not being produced by renewable energy sources, but the energy is very, very much shifting at pace to renewable energy sources. So that's why I quoted those International Energy Agency stats. If the energy going into the production of the vehicles and the fueling of the vehicles is renewable, entirely sustainable, then electric vehicles are an entirely sustainable new transport mode.
And so, Patrick, how do you go about building an electric vehicle? And how can robots help with this change?
In a typical EV battery, there is a cooling plate down there that's as batteries and electric motors pull energy through them, they create heat. We need to take that heat away from the battery, and to do that, we apply thermal interface paste between that battery module to that cold plate. Traditionally, we've seen these things as, I'll call it dual-sided tape. And if you can imagine trying to put dual-sided tape and peeling the one piece off and sticking it on and you have it all over, it just becomes terribly difficult. Well, we have now robotic solutions that can dispense that thermal interface paste directly onto the cold plate, and then when you press the module down onto that, it then completely covers it so you get good heat transfer. That's one key area that we see robotics help. Batteries are heavy, and the electric motor, while it's small, it's very dense and full of many magnetics and steel and copper, and they're very heavy. So what we're doing is we're having robots do a lot of that heavy lifting and placing of those battery packs and those electric motors. And then finally, the newer pieces of it, we're having robots work cooperatively and collaboratively with operators, putting them right in the same workspace. We're taking down the big Jurassic Park fences to keep the operator and the robot apart. And with the new collaborative robots, we are using them in cooperation with operators to really help them do more things like vision inspection and fastening and ensuring that everything is torqued down on the battery accordingly, or the electric motor. So those are some of the really key things that robots have been helping and working with our customers in the building of EVs.
Now let's go under the bonnet, so to speak, and find out a bit more about how robots can help us make these cars go. We're joined by Isobel Sheldon, Chief Strategy Officer at British Volt. Hello, and thanks for joining us.
You're very welcome, and it's my pleasure. Hello to you too.
So, Isobel, tell us a bit more about British Volt. What is your company all about?
So fundamentally, British Volt is setting up a large-scale gigaplant in the UK. Now, a gigaplant is a very large manufacturing facility that makes batteries for electric vehicles and heavy-duty markets. So it's a 30 gigawatt-hour manufacturing facility that will be based in the northeast in Blyth in Northumberland. And this is a huge undertaking. It's going to be the 16th largest building in the world, and it's also going to be the 4th largest building in the UK. If you drive at 60 miles an hour past it, it's going to take you about 15-20 seconds just to drive past the building. So an enormous undertaking, desperately needed for the UK and the European car industry, because there's a shortfall coming in battery capacity over the next couple of years.
That is massive in so many ways. So, Isobel, let's start with the basics. What is a battery cell?
So a battery cell fundamentally is a device that stores electrical energy. So you charge it up, you store the energy, and then you discharge it when you need it. And these fall into two areas, really. You have what's called a primary cell and you have what's called a secondary cell. Now, a primary cell are very much like the Duracells and the Evereadys, the one-off batteries, single-use batteries that you'll put in your torches and in your remote controls for your televisions and stereos. When you come to electric vehicles, quite clearly you can't replace the cells every time you drive it. So you need to have what's called a secondary cell, which is a rechargeable battery. You have cells, you have modules, you have packs, battery packs in the automotive world. Anything that's not a single cell tends to be called a battery pack.
And how many battery cells make up a pack, and how many packs do you use in an EV?
So generally you use one pack in an EV, and generally one pack could contain several hundred cells or up to 6,000 or 7,000 cells, depending on the size of the cell and the size of the pack.
And how do you go about making a battery cell? Talk us through the process.
It's really quite complex. So you have a variety of processes such as mixing, coating, drying, winding, stacking, and then charging and discharging and quality checks at the end. So this tends to be quite a long and complex process and requires a lot of equipment to deliver that accurately and at the correct quality levels.
And that's why you need such a big building, right?
That's why you need a very big building, yes indeed.
And in all of that process, where are robotics involved?
Actually, most of the equipment, for the cell assembly process, so the winders and the stackers, they actually have robots built in, and these tend to be 3-axis robots, not traditional armed robots, but gantry type robots that will come and pick up materials and spin them around and put them into place. Where a traditional armed based robot will be used within our facility is moving materials between processes. So fundamentally we want to keep the process really efficient, so we want to pick up materials off the back end of one process and get it into the next process as quickly as possible, so we don't have that material hanging around. If material is hanging around, it costs us money. And if it costs us money, it makes the product more expensive at the end of the day. So we need to have a very efficient and slick manufacturing process. And materials handling between processes where the robotization will come into the facility itself and help us maintain efficiency and help us maintain, limiting the damage to materials. Where human beings go and pick things up, they tend to drop them or knock them onto stuff. With robots, you can describe very, very precise paths for those materials to be moved through, and we can minimize that risk of damage and improve our yields.
And I can imagine you're having to produce so many hundreds and thousands of these cells. And how do robots help in the numbers that you have to produce?
We are talking up to, for the full-scale facilities, somewhere close to 1 billion cells a year once we have it all set up and running. We'll be producing 3,000 cells a minute. So quite clearly we're going to make some people very, very bored if they have to pick that stuff up and move it around. It's just a factor of the volume that we have to do. We need to have automated systems to make sure that we've got the robots doing the jobs and we can get the people that we need to employ to do the more interesting stuff.
Could you produce the cells in that higher number without robots?
No, you just wouldn't be able to do it.
It's been absolutely fascinating to talk to you. Thank you so much for joining us. Isobel Sheldon, the Chief Strategy Officer from British Volt.
Thank you. Thank you for allowing me the time to talk today.
We all know that EVs are here and they're here to stay, but they're not necessarily being taken up by the mainstream in the way that we would all like to see. So, Ade, what do you think are the technical and social challenges around this?
There are definitely challenges. So the manufacturers need to start producing the models that are attractive to consumers. I mentioned charging infrastructure earlier. That's still a big problem. There's still an issue around the availability of charging infrastructure, and people are concerned about that. People talk about range anxiety around the idea of driving an electric car outside of the range of the car. So an electric car has typically a range of between, depending on the model, kind of 150 to 300 miles of range. So, people are nervous about driving outside of the charging infrastructure that they know, typically in their own domestic home charging environment. As soon as you get into the realms of public charging infrastructure, it can be a little tricky to find charge points that are available, that work, that you have the right connection to, that you have the charge card for, the account for. It is a tricky environment out there for charging, but it's an environment which is changing extremely dramatically and rapidly. Governments and the private sector are investing at scale to deliver exciting new charging infrastructure solutions.
And Patrick, talking about these technical side of things, what's proving difficult in your field?
To bring the cars to market faster is probably one of the biggest changes we've seen and proving to be difficult. And the other piece of it is really constant change. The technology's changing. What's going in batteries, what's going in electric motors, how they're doing it is changing constantly. So for one thing, timing. I mean, we used to see the large automotive manufacturers bring cars to market in 3 to 4 years. Okay, now we're seeing the EVs and the startup companies and even those older schooled 100-year-old companies bringing vehicles to market in 2 or 3 years or even less. You're not going to bring the vehicle to market in 4 years because the technology and the battery is probably already changed before you launched it. Okay, so the velocity of bringing it to market is really a key. So we see that. The other thing is cost. Auto manufacturers are desperately trying to reduce the cost of an EV vehicle. And today they're still more costly, but that number is coming down and we expect it to continue to come down. So they're looking at everything, even beyond how they build batteries, electric motors. They are looking at every piece of the vehicle and how to take cost out of that. So what we're seeing is, in a couple of examples of this, is we're seeing that car companies are now starting to cast more pieces. Before they would stamp out pieces and then they'd have all those pieces put together in a jig and then a robot would come in and weld them all together and then that would be added to more robot welding and then we'd build the car. Well, now what we're doing is casting massive pieces of them, okay, and that's going to change how not only an EV is made, but also how a traditional car is made. So we're seeing those changes.
Because, of course, the more of the car that you cast, the cheaper it is because the less work you have to actually do to get all of those bits put together.
Exactly. It not only reduces the cost of the raw materials going in, it reduces the cost of the automation that you've got to buy to assemble it. It reduces the size of the plant you need to build it in. It reduces across the whole value chain. So it's really key. And then also within the powertrains, we have robots that are assembling things more and more precisely, cost effectively, and we're really trying to reduce the cost, increase the efficiency. One of the things that many manufacturers find that it's really easy to build one or two cars, okay? Hand building a car is really easy to do. But when you got to scale it and you got to build 400,000 of them in a year and you got to do it all cost effectively and you got to maintain your quality, because we as consumers, if 1 out of 5 is not so good and would have to go back, we'd be quite mad if we got the 5th one, okay? So they got to scale, and that's a huge problem for that. And what we see is robots are here to help them really help that scaling and keep that efficiency and keep the quality level so they can produce more of those vehicles at the same volume and sell and drive the cost down so we can sell more of the EVs.
Ade, have you got anything to add to that?
Yeah, I was listening to an interesting interview with Elon Musk recently, and he was saying that it's not making the machines, i.e. the cars, that's the complicated bit. It's making the machines that make the machines. So ABB's work on the robot side is a crucial vector for delivering the rapid shift to electric vehicles.
That's a beautiful phrase, and that's true for so many things. Over the last few years, there has been an increased uptake of EVs. And Ade, do you think this is where the future is going? Do you think it's just a phase or it's here to stay?
Elon Musk says there is a 0% risk that there won't be a demand for electric vehicles, and I totally share that sentiment. I think we are in the white heat of a total transition to electric vehicles. It's by far the better technology. The drivers for change for the automotive sector are coming from outside the automotive sector. They're coming from climate change. They're coming from better technology with electric vehicles. They're coming from Swedish schoolgirls in the form of a global campaign movement started by Greta Thunberg. So all the drivers for change mean that this shift to electrification is an absolute inevitability. We are experiencing an iPhone moment at the moment. There will be a total and utter transformation in a few short years to battery electric vehicles. I'm totally convinced of it.
And I'm excited for that moment. It can't come too soon. Patrick, do you agree with what Ade said?
Absolutely. I think they're going to replace the ICE as once the EV was replaced by the ICE. And it's just a matter of time. Many argue that, the EVs are not so green because you're digging up raw materials and spending the fuel on that. In the future, the batteries are going to be made from recycled batteries. So at some point in the future, we're not going to be digging up all those materials. We'll have enough dug up and done. So that'll go away. We always have the debate on, you're charging your car through an electrical power plant that basically is producing coal. Well, those power generation plants are changing over and they're becoming more green and they're doing more solar and wind generation. And the key to that is when you change one power plant, then if all the EVs on that directly get that impact of that one power plant upgrade or change. Unlike a traditional gas engine, if we upgrade the power plant, they still produce all the CO2s because we have the combustion engine out there. So for sure it's going to change, and for sure they're going to stay here. And it will be an inflection point sometime in the future that will change it. It's bound to come. I think it's clear that most people are getting prepared for it.
So let's imagine, right, a future world where we are all driving the battery electric vehicles. As many people as can are doing so. What impact will this have on our emissions and our lives?
Yeah, for sure, the impact is going to be significant. We're going to see the changes in the environment, and the reduction of both the emissions and the whole how we go to market for how we buy automobiles, who buys automobiles. I think that's all going to change when we start to also add in the autonomous automobile in that, which is really leveraging heavily from the electric vehicle. I think we're going to see a wholesale scale change of how we really look and purchase our automobiles in the future. So, and I think you're going to see maybe even less vehicles in certain city places because there are going to be ride shares. People are going to, go out and jump in the electric vehicle. The electric vehicle is then going to self-drive itself to wherever you want to go. And I think it's going to change. You're going to see many infrastructure changes to support that. And you're going to also see just a really trend in the whole how we've purchased and the whole automobile industry as a whole. So,
you asked a question about our futures. Without wishing to be too apocalyptic, if we don't make this rapid transition to decarbonize the energy and the transport systems, our children won't have a future in very many cases. There will be some pretty catastrophic consequences if we don't rapidly decarbonize these systems. So the imperatives to do so are enormous, not just for the sake of our children's, but for the sake of humanity, really. And governments and large companies are keenly aware of that. So the policy framework and the sustainability drivers coming from governments and large global corporations are keenly aware of that pressing imperative. So our future absolutely depends on these very rapid transitions.
It's a future I want to be now. And that is all we have got time for today. Thank you so much to our panel, Patrick Matthews from ABB, Ade Thomas from Green TV, and also Isobel Sheldon from British Volt. Next time, it's the last episode of the series. Sticking with Going Green, we're going to explore how robots can help engineer a more sustainable world. Join us then. In the meantime, please drop us a review on Apple Podcasts. And don't forget to subscribe to the Robot Podcast so you never miss an episode. I'm Fran Scott, and the Robot Podcast is a Fresh Air production for ABB.
Part of the ABB Decoded series.